So here's the Trello sheet. So we'll start slow, see what methods can be used, how we choose methods. How you choose the method. Let's see if we can get where. Don't worry about the limits. Let's do the subject. So question 4. At sheet 4. We start with question 1. A. Part 1. So we have the integral 2 plus 3x to the power 2 divided by the root of x dx. So if you look at this integral, really it looks like a fraction, as if we must do substitution, but then there's no much work here. If you look at the numerator, you can easily expand it to 4 plus 12x plus 9x squared. And then we can write root x as x to the power half dx. So now we can start dividing each part of the numerator by the denominator. So we have 4x power minus half plus 12x 1 minus half. Remember, when the bases are the same, you subtract the powers, plus 9x squared, so 2 minus half, and then this whole thing dx. Okay, so we can do the addition of those powers. So we have the integral of 4x minus half, we leave it the way it is, plus 12, 1 minus half, that's half for x, plus 9 x, that's 3 over 2 dx. From there now, we start integrating. So we have 4x, negative half plus 1, that gives us half, over half, plus 12x, half plus 1, that's 3 over 2, over 3 over 2, plus 9x, 5 over 2, if we add the 1, over 5 over 2, plus a constant c. Now the job remaining is just to write these fractions. So here we have 8x power half, which is the same thing as 8x, and then plus the 3 into 12 goes 4 times. 4 by 2, we get 8. So I can leave this as 3 over 2 plus 9 by 2, that's 18 over 5, x to the power 5 over 2 plus the constants. So I want you to be comfortable with the method. So immediately you lag behind, please ask. Because integration is mainly understood when you're doing the basic methods. And this is one of the basic methods that we have used here. We have used extended power. Is it fine? Let's see the second one. The integral of 3 over 4 e to the power 2x dx. So we're now dealing with an exponential function. So when integrating, the constant 3 over 4 could actually come out of the integral. At this point, you differentiate the power. You differentiate the power for e. So keep the 3 over 4, differentiate the power for e. So the power for e is 2x. If we differentiate 2x, we are going to get 2. So that 2, we divide it and then add c. So we have 3 e to the power 2x over 4 by 2, that's 8, plus c. Okay. By 3, another nice one. So we have 6 to the power 3x dx. So now it's not p, it's 6. So here, let me take you to what happens if we ask you to differentiate this function. If we are asked to differentiate 6 to the power 3x, what would be the derivative? The derivative here, if you remember the exponential and the mean combination, this one gives us 6 to the power 3x multiplied by 3 to the 6, where 3 is the derivative of 3 power, of 3x of the power m. So if this is the derivative of this, it means that to integrate that one, well, you write it out 6 to the power 3x divided by 3 in 6, and then add the constant. So that if you differentiate it, it will take you back to the question. Remember, when you differentiate the answer, you must retract, you must get the question. And that's how sure you are that, oh, what I've done here is correct. Is it okay? Thank you. So,
yes, it is okay.
And that. So now we go to part 4. What's the integral of 2 cosec squared of theta with theta? So what's the integral of cosec squared? There's actually a function that when you differentiate it, it gives you cosec squared.
Out.
It's it?
Cot theta.
Cos theta. Okay, let me show some people where those things are found. So here is where I'm getting the feeling. How we can choose. So here is where most of them are coming from. So there's a function that when you differentiate, if you differentiate cot, you get minus cos x squared. So to integrate cos x squared, you need to get cot. Okay. So you need to get that. So let's go back. Let's see. So you would say, okay, since I know that the derivative of cot theta is equal to minus cos x squared theta, now we have a 4. So we must just take care of it. And then we can take the 2 outside so that we remain with cos x squared or theta and with theta. So in integrating, the first thing we write is that minus there. So we put the minus because it's not there. And then 2, and then now bring the cot theta, cot 4 theta. Then this 4, which is not accounted for in here, becomes the denominator. So you divide by 4. So that you know if I differentiate, I'll use chain rule, I'll differentiate 4 theta and I'll get a 4. So it will be cancelled by the 4 that we place in the denominator there. So this means if we divide, we get cot 4 theta over 2 plus c. Like that. Okay, so let's go to the other one, part 5. The integral of 4 over 3 take 4t and 4t dt. So there's just an error there. It can be dx. It has to be dt. So here, again, we take the 4 over 3 outside. And keep this. So again, I remind you, if you differentiate sec t, you get sec t and t. And the derivative of sec t. So it means that here we have 4 over 3 sec 4t and then divided by 4 plus c. Because this 4 thing is just a derivative of sec 4t. So that we remain with sec 4t divided by 3 plus c. Okay. So I'll leave the 6th one for you to do. For you guys to try this one. The integral of 2t cosec 2t dt. Again, I can remind you that the derivative of is it of cosec t is cosec t cos t negative. Okay, so let's confirm. So I have it here. Derivative of cosec u is minus cosec u cos u. Yeah. So it's here. Number 80. Okay. So you use this one to try this 7. Let's go to B. That was A. We'll go to B. So what's B? Okay, here. So B is this guy. The first one on B is the integral from 1 to 3 of 2x squared plus 1 over x dx. So the first thing I do is to prepare the thing for integration. So I divide by x, I get 2x plus x to the power what? So let's write it as 1 over x. Yeah, dx. Then integration you can split. So we have the integral from 1 to 3 of 2x dx plus the integral from 1 to 3 of 1 over x dx. So the integral for 2x is 2x squared over 2 from 1 to 3 plus the integral of 1 over x is linear from 1 to 3. So you substitute. Where there's x, you put 3, you have 3 squared. That's 9. 9 by 2, that's 18 over 2 minus. Substitute 1, we get 2 over 2 plus ln 3 minus ln 1. So here we have 9 minus 1, which is 8, and then plus ln 3. Since we know that ln 1 is 0. Okay. Interesting is part 2. From -1 to 2, the integral of 2 over 3 e to the power 2x dx. So now that e is in the denominator, what do? You start panicking? No. You take it back where it's supposed to be. So, and the 2 over 3, remove it. And then take it back. We just give it a negative part. And do the normal integration. So we have 2 over 3. We integrate that, we get e to the power minus 2x over minus 2 and run from -1 to 2. That is this guy and that guy. So we have e to the power minus 2x over minus 3 from -1 to 2. If you place a 2 where there's x, we get a -4 there. So we have e minus 4 minus, we place a -1, we have e squared, everything over -3. So we can leave it like that. You see, nothing hard there. We got part 3. We're integrating from pi over 4 to pi over 2. 3 sine 2x minus 2 cos 3x dx. So again, these 3 can go outside. Then we integrate sine. So we get minus cos 2x over 2. And then minus, that's 2. Then the integral of cos is sine for 3x again over 3. And then now we bring the angle from pi over 4 to pi over 2. So we substitute. Where there is x, when we put pi over 2, we get pi. Pi is 180. Because 180 is -1. So we have -3 minus 1 over 2 minus. Here now we have 3 pi over 2, that's 270. And sine 270 is -1. So we get positive 2 over 3. And then we subtract. We now substitute pi over 4 here. Going to be pi over 2, which is 90, because 90 is 0. So that is just 0. And then remember there's a minus, so that guy becomes a plus. Again, we plus 3 pi over 4. So what is 3 pi over 4? That's 3 by 180 over 4. That's 135. 135 subtracted from 180, we get 45. And since it's sine in the second quadrant, so we have the positive value. So sine 45 there is √2 over 2. So these will cancel. And then, so we get 3 over 2 plus 2 over 3 plus √2. So we have 3. So that's the 3. And sit down there. And the 6 because of 2 and 3. So 2 and 6 are 3. So we have a 9 up. Plus 2 by 2, that's 4. Plus 2, which 2. That's 15. Plus 2, which 2. Over 6. For the issue of substituting, that should not be a big deal. Then we move to question 2. We move to question 2. Where is question 2? By using the appropriate method, integrate each of the following. Question 2a. So question 2a, part 1, you have the integral of x minus 2 over x squared minus 4x minus 2 dx. So when you have such a thing, it's a fraction, but if you look at the fraction, well, it looks like we can easily let the denominator be u, and when we try to differentiate it, it will be related to the numerator. So if we differentiate this guy, it will give us 2x minus 4 dx. Okay. So if you can write the du as 2x minus 2 dx. So if we divide by 2, we're getting a du over 2 to be equal to x minus 2 dx. So I've gone for x minus 2 because I can write the equation as x minus 2 dx over x squared minus 4x minus 2. So now let's substitute. So we'll have the x minus 2 dx to be the same thing as du over 2. But then there's a u down here. So I can put the 1 over 2 out and remain it with du over u, whose integral is ln u plus c. But what's u? U is x squared minus 4x minus 2 plus the constant c. So you see, we've not finished using substitution. We've stopped dividing just. Let's see the second one. It's the integral of 4 over 5x minus 3 dx. So again, if you let u to be 5x minus 3, du is going to be 5 dx. Also, if we divide by 5, we'll have du over 5 equal to dx. So that when we come here, we can now write things as 4. Dx is du over 5. And then the 5x minus 3 is actually u. So this can be written as 4 over 5 integral du over u. So again, it becomes 4 over 5 ln u plus c. So that we get 4 over 5. What's u? U is 5x minus 3 plus c. So remember, we are saying ln because if we differentiate ln of u, what we get is the derivative of u over u. The derivative of u is only according to du over u. So that's why when integrating the du over u, we go back to the u. Interesting. Okay, let's pause for questions. I think this is where we'll break for this night. since integration has been introduced, because now I can see B is integration by parts and C the trig integral where we do a bit of some double angle formulas. And then G, again, the combination of the trig. Question 3, now that should be trig substitution there. And then 3B, that's partial fractions. What about 3C? 3C is magic substitution. And then 4A, again, a mixture of functions by parts. Then the reduction. Okay. Could we have any questions from this session? So if we don't have questions, then we can have this for Friday. And we wait for 1 year to the back.